Dear students, greetings. In this series of video class, we are discussing transaction processing concept. In this video class, we will discuss concurrent execution of transaction. I am Arun Kumar, Assistant Professor in MLB Textile Engineering College. This content I have taken from database system concept by Korth. Concurrent execution of transactions. When multiple transactions are allowed to run concurrently or simultaneously in the system, we call it concurrent execution of transaction. When means more than one transactions are executed simultaneously. So there are several advantages of concurrent execution. The first advantage is it increased processor and disk utilization, and also it's increased throughput of transactions. Means the per unit of time we are executing more transactions. And the second advantages we can get is reduced average response time, because there is many kind of transaction which required less time, and some transaction need more time. So because of this concurrent execution, we can get we can reduce our average response time. The second thing is using this property we need to uh, consistent our database. More than one transaction are execute simultaneously. Cause of this we can lose our consistency of database. So there is one mechanism, concurrency control mechanism, or concurrency control scheme. It used to achieve isolation is the one of the property of transaction, that is to control interaction among the concurrent transaction in order to prevent them for destroying the consistency of that database. Schedule, as in the last class we have discussed what is schedule. Schedule is nothing but series of operation as executed by database management systems. When more than one transaction are executing simultaneously, there is many operation. A transaction have many operation, other transaction have several operation. When these operations are executed parallelly, so in which order these operations are executing, that order we called one schedule. A schedule for set of transaction must consist all the instruction of those transaction. Means if suppose a transaction 1 has 5 operation, transaction 2 has 3 operation, and transaction 3 has suppose there's 7 operation. So the a complete schedule which contain all these 3 operation will have first transaction 5 operation, 3 transaction of second operation, and 7 operation of other transaction. Means the total 5 plus 3 8 plus 7 is 15. Means all the 15 operation will have this schedule. The second properties of schedule says that it must preserve the order in which the instruction appear in each transaction. Means transaction, suppose transaction we are talking about the transaction 1. If transaction 1 has 5 operations, then always we have to preserve this order. Means a transaction has 5 operation 1, operation 2, operation 3, operation 4, and operation 5. So we have to preserve the order of this operation to execute. Means operation 1 will execute first, then second, then third, then fourth, then fifth. Means this order of the particular transactions operation we will have to preserve. The third the next point is a transaction that successfully complete its execution will have a commit instruction as the last statement. Means when more than one transaction are executing parallelly, when a transaction has successfully completed all operation. Means we are talking about the first transaction, it's a 5 operation. When transaction 1 has completed execution of all these 5 operation, we will set commit at the last. Means by default the transaction assumed to execute commit instruction as its last statement. Means this transaction has been completed successfully. If a transaction that fails to successfully complete its execution, will have a abort instruction at the last statement. Means again we are talking about the transaction 1. If transaction 1 has the 5 operation, and suppose there's an only 3 operation has successfully completed and some kind of failure occur, then we will call this transaction, we have to set this transaction is abort, means this transaction is not successfully completed. We have to set the abort instruction at the last. Let's see one schedule 1. There's two transaction 1 and transaction 2. Transaction 1 is transferring $50 from account A to account B, and transaction T2 transfer 10% of the balance from A to B. Means what is the 10% of A? 10% of A balance. We are transferring that 10% of the balance of A into account B. These are the two transactions. Here we can see transaction 1 will read current balance, then it will deduct 50 rupees because we are transferring $50. Then it will write the value. After deduction it will write the value, then read the value of B, what is the current value of B, then add that 50 rupees which subtract from account A and write B and commit. Commit means all this 1 2 3 4 5 6, all 6 operations is successfully completed. Then we will set commit. Commit means this transaction T1 has successfully completed. In the same way, transaction T2 is transferring 10% of the A. So it will read what is the current balance from account A, then in temporary variable temp, and what is the 10% of A. Suppose current account balance of A is 100 rupees, then 10% of 100 equals to 10, means temp value will be 10. Then we will deduct that 10, the temp value. A means current value minus temp value. If A value is suppose 100, then temp value will be 10. So means 100 minus 10, A value will be 90. So the new value A will be, we will write. Then again read B. What is the value of B? B means current value plus temp. What is the value of temp? Temp is 10. So current value plus temp. Suppose value of B is 200 rupees. So 200 plus 10 means 10. 200 plus 10 is 210. So the new value of B we will write into B is 210 and commit means that this is the last instruction. All this 1 2 3 4 5 6 7, all 7 operation of this transaction T2 has successfully completed. Then we will set its commit, means this is the last instruction of this transaction T2. In the same way, next is schedule 2. In this schedule we are performing transaction T2 first. All the operation of transaction T2 we will execute first, then other all the operation of transaction T1 execute. So this example, schedule 1 and schedule 2 is a serial schedule. Serial schedule means one after another. We completely execute one transaction, then execute other transaction. Here we completely execute transaction T2, then transaction T1. So it is a serial schedule, one after another. We execute completely one transaction, then we start the other transaction. And here you can see schedule 3. It is not serial schedule because it's executing several operation of transaction T1, then some transaction of T2, then some operations of transaction T1, and last some remaining operations of transaction T2. Means we are not executing this transaction in serial order, means one after another. We are executing some operations of a transaction, then some operation of other transaction, then several operations of one transaction and several operations of other transaction. Let L1 T1 and T2 be a transaction defined previously, as we have seen. The following schedule is not a serial schedule because it's not executing one after another, but it is equivalent to schedule 1. What I want to say here, this is not a serial schedule. What is equivalent to schedule 1? Equivalent to schedule 1 because the consistency in schedule 1, it's also preserve that consistency in schedule 3. Then if two schedule have the same if they maintain the consistency of database, we can call this is a equivalent schedule. Here in schedule 1, in schedule 1, 2 and 3, the sum of A and B is preserved. How this value is preserved, let's see from let's start from the schedule 1. Just 1 minute, let's pen. Suppose the current value of A is 100. Current value means the balance is 100. We read that 100, then deduct 50. 100 deduct 50, then it will be 50. Then write 50. Read B. Suppose the current value of B is 200. Just consider and write 2 and commit, means transaction T1 has been completed. The initial value of A is 100 and B is 200. Let's make this instruction we have not executed. 200 plus 50 means it will be right 250. So after completing the transaction T1, the new value of A will be 100 and B will be 250. Then transaction T2, its read value of A is 50, 10 temp, in temp another variable temp. Temp value will be 10% of A. A value is 50 and 10% of A is 5. Then it will deduct A minus temp. A value is 50, temp value is 5. It will write it 45. Write 45. Read B. Read initial value of B is 250 and B plus temp. What is the value of temp is 5. When it will be write 255. So after completing both the transaction T1 and T2, what is the value of A plus B? Initially it is 100 plus 200 is 300, and after execution both the transaction, A is 45 plus what is the value of B? B is 255. 45 plus 255 is also 300. Means it's maintain the consistency of data consistency of our database in schedule 1. Again check the consistency for transaction or schedule 2. In schedule 2, let's again just consider value of A is 100 and B is 200. Just initial value we are considering. Read A is 100, temp another variable temp is 10% of A. What is the 10% of A? 100, 10% is 10. A deduct temp is 100 minus 10 is 90. Then write A is 90, value is right. Read B is 200, B plus temp. V current value is 200 plus temp is 10 equals to 200 plus 10 is 210. After completing the transaction T2, this is the value of A and B. Then transaction T1, it will read value of A is 90, deduct 50. Of 90 minus 50 is 40, and write A, means the 40 value of A will write, and read again B. B's current value is 210 and add 50 rupees. 210 plus 50 equals to 260, and write B 260. Again check the initial value of AB, and after completing this schedule value of A plus B. Initial 100 plus 200 is 300, and after completing this schedule transaction T2 and transaction T1, 40 plus 260 is 300, means it's consistent